Can you hear? Yes, this should work better. Okay, sorry for that. Hopefully now it works well. Let me know if it doesn't work. So today we are going to talk about um, basically we have 3 topics as well as a Q&A. So first part of it is the idea of coroutines. So coroutines is a kind of kind of advanced feature of Kotlin. It's not as easy to get used to it as you might like, but it's very powerful. I encourage you to have a look at the documentation that I have a link to here, because it really helps you to understand what is going on. They have improved the documentation a lot since they started with this. It's still, I think most of the work has been done, but they are still adding lots of features to it and capabilities to when you're using coroutines. So what are they? So coroutines, there are 2 parts to it. Part of it is they are kind of a little bit like threads, but threads have a problem, is that they are very expensive to use. When you create a thread, you basically create a whole new process with a whole new stack. And it goes all the way into the operating system. So you cannot create 100,000 threads on a normal machine without incurring massive overhead. It just doesn't work. With coroutines, you can actually get away with doing a lot of those things because they work in a different way. They are implemented on an application level, and they just basically, they don't need a stack. They use the stack of the thread that executes the coroutine when it's being executed, but then when they are not being executed, they use something else. But they are just, that stack is used for another coroutine or for nothing or whatever. They don't have a separate stack. So they are much cheaper to execute. They also have some other advantages in that they can allow for much nicer asynchronous code. So what does asynchronous code mean? Asynchronous is related to the fact that sometimes you want to be able to so you have things where you say, okay, I'm going to do this, say download a file of the internet or download a picture or whatever, and when it's there you need to do something. So how do you do that? Well, you can do it synchronous, which basically means, okay, I'm going to wait, the world stops, nothing happens until it's there, and then I'm going to process that. And when I finish processing it, then I'm going to return my function, and maybe the operating system can get control then. You do that in an Android application on the main thread, you get a very unresponsive UI. So how do you deal with this synchronous? Well, you start a thread that does this work. Why not reuse a thread? Sometimes you can reuse a thread. There's an idea called a thread pool, but again, if you're doing multiple of those things, you might still be waiting for those threads to even be started or a thread to be available. Of course, you can start as many threads as you want, but that comes with the overhead of having a thread. Coroutines make this better. But at the same time, what you get if you use use those threads is maybe you have one thread and then starts something else. It's not very easy to write. So as an abstraction over that, a common abstraction is something called callbacks. Basically, you start a thread, and when it's finished, it will say, okay, when I'm finished, I will call your function. And then you can do that. The disadvantage of that is that, and I will have an example of that later, some code, is what you can get is what we call callback hell. Basically, you get very deeply nested callbacks where error handling is not necessarily straightforward. And so it doesn't work the way we'd expect or hope it to. But you cannot only use it for multi-threading, but there's actually also an easy approach to use it to create sequences of stuff. So that is another one that hopefully that I will show an example of how that actually is implemented. Because coroutines are basically a way to kind of return from a function when it's not finished with a state object, and when it's then finished, and then you can continue the function given that state object. A continuation, they call that object. And when we look at the actual implementation of coroutines, we will see a little bit more. So what are the key fundamentals of what makes this work? So there is the suspend keyword. So the suspend keyword basically is a keyword that you put on a function, and it transforms this function so that it can be suspended. So what it does, it is that it changes the return type, for example, but it also adds a parameter for the coroutine status, so that your function actually knows which coroutine it is, and it can do this correctly, and it can interact with the coroutine correctly. And this all happens underwater. It also changes the actual code implementation, so that if you know that you need to continue after calling the thing, you just pass the right information into the function, and it knows where to continue. All of that is handled automatically for you by the compiler, because the code that is generated isn't necessarily straightforward. That's the disadvantage of coroutines. They actually require different bytecode, where if you have a thread, you can just use the same code in the thread, perfectly fine. If you have a suspending function, it needs to be able to handle this correctly. And there is the idea of a coroutine scope. And this was added to the system after the initial experimental version, because what happened was basically what the coroutine scope does, it provides a context for coroutines. So if the coroutine scope stops, it can also stop all the coroutines inside that. Or if one of the coroutines in the scope crashes, it might or fails, you might want to stop all the other coroutines in the same scope. There's a special one, it's the global scope. Basically, it doesn't really have a lifetime, it doesn't get destructed, and of course it also, so if you have one-off standalone coroutines, you can sometimes use global scope. In an Android context, you probably don't want to do this. Instead, you want to use the Android coroutine library, but because for using coroutines, you need to add the coroutines library to your project. And the Android coroutine library adds a little bit to make it work correctly on Android. So how do you start a coroutine then? So there's basically 3 launchers. There is the run blocking launcher, and the interesting thing about run blocking is that it doesn't come with a coroutine scope. It creates its own coroutine scope, but what it does, it just runs the code and only finishes once all the coroutines that were invoked inside the block have finished, and then it returns the result of that code block. And run blocking is something like if you want to have a main function that is accessible through your that supports coroutines, you can just use run blocking. One thing is that while you can only call suspending functions from a suspending context, so from inside something that is suspendable, like has use the launcher at some point to create a coroutine, etc. You can you can call regular functions perfectly fine from a suspending context. Then the second one, and one that you will use quite often, is the coroutine scope.launch function. So that is a function on coroutine scope that then allows you to, so that's the interface, that allows you to launch a new coroutine inside that outer scope. That means that when you run this thing, when the outer scope closes, it cancels the jobs, or if one of them fails, it will fail, the other ones get cancelled. Because coroutines can be cancelled, and there's a way inside your in your suspending function to actually check whether the coroutine has been cancelled, so you don't do any more computation. Then there is the async function, and that is a little bit separate, and I will come back to that later. So async allows you to basically do start a computation, but defer it, and get an object that basically gives you the value, but it basically says, okay, get started on this. When I really need you, I will ask for the value. And what this has as an advantage is that you can just basically run coroutines in parallel. A cool part of this is that you can actually use async with a parameter that makes it start lazily. That means it will only even start the coroutine once the value has been requested in one way or another. But I said I would come back to this sequencing stuff. So Apache also has an idea about how this works. So what you can do with the sequence generating, so the sequence function is an inline function that you can use to create sequences. But what is interesting is that rather than you having to create somehow a list of things that you're returning, you are using a generator function. An inline, so a function that just calls yield a number of times. And it doesn't use threads or anything. So it produces basically an iterator that just loops through your function, and every time you call yield, it will be provided as a result to the caller, and when it needs yet another value, it will continue your function a little bit, etc., until at some point either your function returns or the iterator is no longer used and your continuation object gets garbage collected. So how is this actually implemented? So I have here a shorter version of the actual implementation of this code in the standard library. So I changed this. So first of all, I ripped out all the comments and stuff like that because it's slideware. We cannot fit everything on the screen, unfortunately, if we put the complete code there. So basically, we can see that sequence is implemented merely as calling creating a sequence object with a particular iterator from that block. You may know a sequence is just an object that creates an iterator when needed. And so that's how this is done. How do you create an iterator? Well, we create an iterator with the particular block. So the interesting bit starts in line 4 on the iterator function. Even that is quite simple. What we do here is on line 5, we create a sequence builder iterator for the type that we are iterating over. And this sequence builder iterator we will go and have a look at differently because most of the interesting stuff happens there. So it implements iterator, but it implements other things. Then in that iterator, we are going to set the next step property to basically to create a coroutine, and this is a special function that basically creates an unintercepted coroutine from the suspend function, where we say, okay, and then we pass it two parameters. So iterator is basically implement some other interfaces with coroutines to make this all work, and we'll go have a look at that specifically. But it basically creates a coroutine and sets that as the next step, or it creates. And when you create a coroutine, you effectively get a continuation, what to do next. Then there is the abstract class sequence scope. So when we look at the function iterator and also function sequence in lines 4 and 1, they take as a receiver the sequence scope T. That sequence scope T, and that's also related to the receiver parameter on line 6, means that the receiver of the function is a sequence scope. So this abstract class provides this. And it says here the sequence scope is a suspend function, and it has a function yield that you can use to provide a value. This is also a place where I took a bit of shortcuts, because in reality there's more functions. There's there's 3 other yield functions that allow yielding collections or sequences of stuff. Basically that adds a lot of complexity to stuff. You can see here in the states below that there's missing values. They have to do with those groups of stuff. So I cut them out to keep it a little bit simple. But that makes that this particular implementation doesn't deal with returning lists or stuff like that. Of course, you can still go and for each element in the sequence or list return it, but that's slightly less efficient than if you use what they call the yield all, and show what this looks like at the end as well. Then there's a number of states. The values are not really important here. They're just integers. So this is the sequence builder iterator, but I have it in, it has a number of functions in it that I have kind of put away the context. So line 17 till 21 or till 20 are commented out, and we'll go back to some of those later. To has, next, and next. Exceptional stage creates an exception. The function yield we do have a look at that. So, but when we look at line 3, so we start our state is not ready. The next value we have is no. We don't have a next value initially. It is in this case, so it's a nullable T, because we need to be able to say initially we don't have a value. And the next step is, what are we going to do once we're there? So note, this is a private class. So this is a class private to the file what it was created in. So even though next step is public, nothing outside of the file in which the class was defined can actually see it, because they can't see the class. So this is actually safe, but it allows the sequence function or the iterator function to actually access this property. So we open up a little bit, but we don't open a massive amount by putting it in this one file. And we have a private function next not ready. Basically, when we need the next, when the next function is called, it can be that we already have the next value, because maybe we called as next, and as next, if we look at it, will actually produce the next value, and then it will store it. Because how do you know that there's a next value? Well, you wait until a yield has been called, or until the coroutine has completed and you know that there is no next value. that so that is what happens. So we need to be able to treat, okay, so when there is no next value yet, what we do is we call hasNext. If we don't actually have a new value because hasNext returns false, we throw no such element exception per the contract of next, iterator's next function. If next is called and there is no value, you are required to throw the no such element exception. That's what the documentation says, that's the contract. If there is a value, we return next again. So we call next, but now we know that it's ready because we have called hasNext. So this makes calling next without calling hasNext work correctly, because there is nothing in the context that requires a caller to call hasNext before calling next. Might be a good idea, but sometimes you know how many values there are and you don't need to do this. You don't need to call hasNext. So then there is the function resume with, because when we look at line 1, we can see that we implement sequence scope, which is our parent class that we defined, that we looked at on the previous class. Basically the one that provides yield. Because if we are providing this iterator also as the scope object, we need to implement that, and we only need one object. Say we could have separate objects with all kind of relationships, but we only need one of each of them. So why not make that the same object instance that does all of these things? It's a private class, so it doesn't matter that you have all these functions in your type. No one is going to be able to access it anyway. So the implementation uses only a single class rather than multiple, and so it implements so it inherits sequence scope with the abstract method. It implements iterator, so it has hasNext and next, and it implements the continuation interface. So the continuation interface is what is needed to be able to work with these coroutines things. It's a continuation that returns a unit. So the end result of this function is unit. So basically the sequence function doesn't return, so the sequence object has no return value. If you have the inside block, whatever it returns is ignored. Only values that are returned through yield will actually be ending up as part of the sequence or iterator. So resume with is called at the end of the continuation when the suspending block is finished. So the suspending block is at some point finished, and then it will be wrapped into a result. So a result is an object that basically very cleverly wraps, so is a simple object that can be either an exception or a value. So that if an exception happened inside the block, this will be stored as an exception, and it does that in a clever way to only use one value. Basically, you cannot return an exception from this, although it might use wrappers or something like that in that particular case, but you wouldn't return an exception anyway. So result will then, what it does is basically it gets the value. So there's different ways of getting the actual value out of a result. One of them is get or throw. So this will get the value if there is a value. If it's an exception, it will throw that exception. So that makes the calling code just get the exception as expected. And in this case, it just, so there's a return value to get or throw, but as we know, it is unit, because it's a result of unit. There's no need to get that because unit only has one value anyway, and we can get at it if we really want to, but we don't. In any case, So we return unit. So here you see a place where having unit is beneficial over having void, because you couldn't have a result of void, because there's no void instance whatsoever. So, and then we update our state, say, okay, now the game is done. We have finished the block, or so now the iterator is done. We finished the block. There's nothing more. So when we then look at the next part, how is this implemented? Okay, so there is one bit. So if the state is not ready, then it will be doing nothing. So that's what those braces do. Basically, do nothing. If the state is done, we say we don't have a next value. If the state is ready, we say we have a next value. And if the state is anything else, then we are somehow in a state that we shouldn't really see. So it calls the exceptional state function to give the appropriate exception. How it determines that, it's not really relevant in this case. It's error handling. So it is also inside the while true. There is some reasons why they do it like that. But basically, so what happens then is that it's in line 14 is that the state says, okay, it's failed. We set the current step value to whatever is the next step property. So we say, so when we look at this one, we saw it starts out as a state not ready. Then we have next step, which is the continuation that we got from here from line 6. So that was the block, that is the parameter. We have a continuation to continue with. That's the next step to execute, one that returns unit. And what we so we get that next step. We set now the next step is null, and then we call on that next step, we call the resume function. Basically, that is say, okay, coroutine, continue your work. And this resume function will then actually basically call the code into the continuation. That was the code that will actually, our code block. So it will call that, and at some point we know that there is a state. So there can be other suspensions that are based on yield nothing or something like that. If it yields an empty list, that should still work correctly, and then we'd have state not ready, and that's why we have the while loop. When we have the next function to say, okay, so we have here where we had this next not ready function that would call hasNext. That is when we have this state, we return that. We have, and hasNext should call next not ready. So when we have the actual state, so when we are ready, we update the state of here now no longer ready, because we are going to have this value invalidated. We get the next value. We need to do a cast to t, because remember, next value was a nullable t. We know that the value cannot be null, or maybe if t is a nullable type, it could still be null. But we need to have the ability to store null, because sometimes it doesn't have a value, and it sets next value to null. There's two reasons for this. One of the reasons is that it helps with having correct code. The other part is that it helps with having code that, say, it means that your sequence builder doesn't hold on to your value longer than needed. And that means that it helps with garbage collection. It becomes garbage as soon as possible rather than leaving it longer. And in code like this, that is always a good thing to do. If we are not in one of the accepted states, we throw exceptional state. And let me quick look how we use this, because there's one function that I forgot to copy in, and we can actually have a look at the actual code. So when we look at, so how do you use this first, and then we're going to look quickly at the code. So this is how you use that. We call a desequence function. Then you can call just yield with a number, or we can call it within a for loop with yield the various numbers. Note that this will just be generated such that, yes, you can stop your execution right in the middle of a for loop. The transformations created are quite clever in that way. You can yield a list of things, you can yield a sequence of things, where the interesting thing is that it will actually hold the sequence and then get the values out of the sequence rather than call your code again. So it will not, the yield all is not implemented as the code block where you have a continuation, basically for all I in list of whatever to call yield. It's actually implemented differently. So let's have a look at the actual code block. I should be able to get there, but I need to set it up very quickly. Let me capture the code. I should have it. So no, this is not getting me the right one. So okay, I will get out of the thing and I will it was minimized. That's why it didn't work. Okay. So I will quickly set this is some other code that I will going to show you later on. Let's go and set the settings to. I'm quickly setting the font sizes to something a little bit more readable for you. So this apply, and then we go to the. So you see now the UI font size, and then I will go and now set the code font size. This should allow you to see what is going on. And in this case, what we are just going to do is create a scratch object. So let me have I'll put it this way so you can see my pop-ups. So we create a scratch. So it's create a scratch buffer, which needs to be a Kotlin one. And so let's do one of whatever. That one might work. So we can have a sequence, we call sequence yield 5, so we can see how this works. Print line, and so we can also yield all of 6,1,3, and yield all is also a suspending function somehow. So this squiggle in the left means it's a suspending function. This is where the IDE actually makes this work correctly. And what we can do as well, so what we can see in the right here is that it has actually executed this, and this works correctly. So what we have done here is effectively turned around the control, where inside our scope, our block, we actually can control. We can just write regular code that just produces values, but when we're using it, we are consuming it. We're pulling it out one by one. And using coroutines, this works in a very clever way, where actually what happens is that the execution of the inner block gets stopped at every time that we didn't get the value out of it. But again, I said we would look at what the yield function does. How is this actually implemented? So we have the sequence builder yield, and when we go to the implementation, so this is what yield actually looks like in this particular case. So yes, you can see that there's yield all and stuff like that, and the other states. So it has a next iterator and a next value to basically handle the two separate things. So a bit of complexity that was not necessary for the explanation. So in this case, we set the next value to be value, we set the state to be ready, and then we call this specific function. So suspend coroutine unintercepted or return. So basically this says, okay, we now need to, this coroutine where we are in needs to be suspended. And this works because it's a suspend function, and these are functions always available to coroutines. So a coroutine has an implicit access to the context of the coroutine. And what it gives us is access to the actual continuation object. Now, in this particular case, and because we now have this coroutine object, we can actually have the ability to say, okay, we now set the next step to that continuation, and we return coroutines suspended. Basically, tell this function that we have suspended the coroutine. We promise we will call the coroutine later on. You don't need to do anything. You can just return execution. So this means that the code will not continue with yield, but actually will continue with whatever code called the coroutine to continue. Or in our case, where we have has next here, we had basically the resume function. Resume calls the coroutine, and we continue with that. In this case, we don't really have a value out of that. So if we call resume, what it will call is called the block. The block will call yield. Yield will update the next value, update the state, update what the next step is, and then suspend this coroutine. So if you would say, okay, continuation, what's your state? It's suspended. So, and then this resume will do that. Then we get back to here in the top of the loop, where we now have the state that is hopefully ready. And you say, okay, we have a next value. Next, we'll actually just, in case we're ready, get our result, set the next value to be null, and return that result. Now, how do we can get back to that continuation? Well, at some point, as next will be called again, we are in the state not ready. So we go into state failed. So state failed is only very temporary. It's like if something doesn't work correctly, it's in the failed state, but if you call yield, it will not be in the state failed anymore. So instead what it does, it says, okay, next step, resume. And how do we finish? So when it's finished, we call this resume with, is automatically called with that result. And then we can set the state to be done, or to handle an exception if it's there. because if there's any exception thrown anywhere, it will always be passed through this result, so that the caller, when we call in our scratch buffer the caller here, so this sequence function will at the end be able to catch an exception. So if we say, okay, throw runtime exception, oops, or something like that, what this will do is when we execute it, we now see it in the right that it would still actually, it should, it should print some bits, but I guess it doesn't in this particular case. I'm not 100% sure. Okay, now we need to run it. No, it doesn't want to work, but the exception should be thrown. And handled. So anyway, so this is how that works. Let's get back to the lecture slides. So that was a very simple usage of coroutines, as in it's actually very easy to use. Getting your head around how you actually use this is a little bit trickier. I fully get that part, but that's what you'd want to do. So when we have a coroutine scope async, we get a deferred. So that is, a deferred is kind of like a future. For those people of you who know future object, it's basically the same thing. So there's something that, yeah, at some point we'll get a value to it. And as long as you don't actually try to get the value out of the deferred, you don't need to wait for anything. You can just immediately continue your code. When you need the value, you get it. And like I said, there is even the ability to pass it some property. So there's a lot of configurability in coroutines. One of them is that deferred, that when you call async, you can actually pass it the lazy parameter or property that makes it wait to start until actually it is awaited. So it will not even be scheduled for execution until there is some code that tries to get the value. And an interesting part is that if you have two values that you are waiting to add up, if one of them causes an exception, the other one will be cancelled as soon as that exception has been thrown, because the entire coroutine scope will be cancelled because of the exception. So the rest of it will just be cancelled as soon as possible, rather than having to wait until the other one finishes to continue. They're not full threads, so they do wait. There is some degree until, so coroutines do need to check themselves whether or not they were cancelled, and stop executing heavy stuff if they are cancelled. And I said a little bit, I would have a look at the anti-pattern. So this is a very simple version of callback hell. This is where you make a request to some intermediate, and then you do something else with the intermediate. You make a request, you get an intermediate result. You do something, then you do something else with that intermediate result. Maybe you first go and look up a user, then you look up their avatar icon, and then maybe you look up some other information from somewhere else about this user. And then you go and store the stuff in the database, and then when it's ready from the database, you're going to update your UI. So you do these various things, and this is actually quite common to have a number of things you need to do in sequence. It's also if you have a dialogue, if you ask the user something and they say, yes, do you agree with that? Okay, oh, I need permission. Do you give me permission, etc. So that is where you get into. up to the point where you then at the end you update the UI. This code is not only kind of ugly and heavily indented, and it gets worse the more you have callbacks. It's not very clear. It's also, there are some rather nasty things that you need to do to actually make this correct, and especially to handle exceptions, etc. It can be done, but it's actually tricky. Especially, how do you get exceptions handled in a nice and tidy way? Whereas if you use the Coroutines version, you get this. So you launch a coroutine, and then you just have the intermediate. I forgot to put the previous intermediate as a parameter to these things. So that's a little error here. I might update the slides for the recorded video. So intermediate 2 is called afterwards, then intermediate 3, and then we have a result, and then we can use the with context function to dispatch this on the main thread, because UI code normally should only be done from a main UI thread rather than everywhere, to update our UI with our result. This is a really straightforward code, except it does not block our UI. And so with coroutines you can actually work with these callbacks very easily, and it's actually not that hard to make a coroutine version of a function that takes a callback. What you need to do there is use the suspend coroutine things, and then in the callback just call the coroutine. Now you can continue function. You call resume in your callback with either an error or the result of the callback. So it's fairly easy to make that work, and it makes for a much tidier code in many places. Then another bit about Kotlin that you may have seen, and that is quite an interesting aspect of what you can do with the language, is something called domain-specific languages. So what is a domain-specific language? In principle, a domain-specific language is a language that is written to solve a problem in a specific, often quite narrow, domain. What does that mean? That means that in that domain, so for that language, we want to talk about concepts in the domain and make it look natural for that domain, so that it becomes very easy to write those things. And Kotlin has sufficient language structures that you can actually make something with your library that makes it look like you have such a language. Of course, it is still Kotlin. It's valid Kotlin. Okay, my camera is stuck. Let me have a quick look. It shouldn't be. My camera is stuck. Oh yes, I see. I can see it's stuck. I can see if I can do something about that. The camera. I'm not sure what went wrong there, but let's see if we can make it work again. Okay, that works again. Sorry about that. I didn't realize that. So, yeah, so this particular slide I might actually indeed make full screen because it's big enough, small enough. So, okay, I think I skipped some slides while trying to make this work. So, what is a DSL? So we want to be able to express things in a domain-specific way. should help with some background light. So what you so basically what you can do is to actually interact with, make things look like another language, to express your ideas very clearly. So, but without, so the other ways that people use these things is they use kind of code generation or something like that. So you use multiple languages in the same project to be able to use a language to specify a domain concept. Or you actually use just strings and you embed those in your code. Where do you use it? For example, if you use SQL in many languages. Or HTML when you generate HTML. But what the disadvantage of that is that you don't have any type safety, you don't have any completion. You might need to do code generation as well. So before we look at the elements of domain-specific languages that make it work, let's have a look at these enablers. So what are the parts of Kotlin that make that work? So particularly what makes it work is the inline functions with lambda parameters, extension functions, infix functions, operator overloading, and there's something called a DSL marker. Another one that actually makes it work quite well is the ability to use to have property delegates, and in particular the overloaded functions to create property delegates make things a lot tidier. So what kind of DSLs can you find? What does it look like? One of the examples is the Kotlin DSL for Gradle. You have been using Gradle. Let's look at it full screen. So when we look at this, it almost looks like it's Gradle in Groovy, which is another programming language that has these capabilities of being quite tidy. But Groovy is a dynamic language, so it doesn't have all this type checking, etc. that Kotlin does. But what you can do, and the Kotlin DSL for Gradle does take a little hack. What it does, it first runs the plugin block, and then it uses what it gets from the plugin block to provide code for the rest. And using that, you have available various concepts that are created by your plugins, basically. So there's 3 plugins here. In this case, in this project, I have my own plugin basically to make it easier to use multi-platform projects. And I don't need to put the code in every file because this is the entire build file. So we still have a description. We have our API. It's Kotlin, so we need to use parentheses rather where in Groovy this is not required. We have our source compatibility, target compatibility, etc. So there's a little bit of differences, but it still looks like our Gradle file, where we have the ability to declare our dependencies. Yes, it happens that these dependency blocks get executed, and then these are function calls that actually result in updating some configuration objects, but we don't need to care. It looks really, really natural. And with this configuration, we can then use that to build our code. Another one is the Kotlin HTML library. This is a multi-platform library. You can use this in JavaScript as well as in in Java, and it allows you to create HTML, to generate HTML in a type-safe way. So in particular, what we see here is an example where I have some function that, so this was something that, so it does a little bit of hacking because it provides this context tag consumer is a tag consumer that I added, that I have created that also as some sort of context because I want to be able to actually use a context for many things. So in this case, what you do here is you basically can create HTML elements. So we need to create a div, and we want to set these are the classes. It's the class property, etc. So you can set properties. You can call child. So the plus here is used to actually add text content. So yes, you cannot get HTML 100%, but you can get something that's really, really tight. I've also played around with this myself for a project I use, and basically this is a DSL for SQL access, because writing SQL can be a bit tedious. Another aspect of, if you do it in SQL itself, then your language, your system has no concept of what the database should look like. What I'd like the ability is that you point me to a database and I will just initialize, create the tables myself or update the tables if and when needed, without specifying anything double. If preferably I don't want to specify how to go from one version to the table to another one. But this is a DSL I created for creating a database. So you can have multiple users. And what you do is, so this is a database, and inside the database there's a number of tables. In this case, we have so extra conf allows you to pass some extra information to, in this case, MySQL that says, okay, this is the character set to use and stuff like that. So what we have here is val user by varchar, and then varchar is configured with these. These are properties that when you call them, they will actually update the setting. So the getter is actually mutating state. This is not necessarily very clean in a normal way, but in this case it makes for a very tidy way of using it without needing to use parentheses. I could use parentheses, but why? So what does this mean? Well, it creates a varchar column named user with 30. An interesting aspect of this is actually, because of the overloading, we could actually leave out user here and it would still be able to know what the name of the property is. And it is actually implemented that works, but I didn't give you an example where I used this. But if you leave, so there's another overload of varchar that doesn't take the name, that will do this correctly. So this is a table definition, and it looks very much like your regular SQL would look, your database definition things. And when you use this, it looks something like this. So this is a function where we create an authentication token for an account manager. So we generate our token, which happens to be just some random number. It doesn't really matter. And then we can say, okay, we have a database connection and we want to update something in there. So we call this update function, and inside there we can actually, the connection knows what the database type is. So we call insert there. We use the capital letters because that fits with what SQL does normally. We could use lower letters, but I thought it would be nice. And this tries to stay very close to how SQL works, but there is a major difference. These column references that come from our previous table, so these this users object has these properties that are columns. So we can use those columns here. So T is basically a shortcut for this particular table. And user gets that column, and what it does, it will actually have all kind of type information associated with it. So it knows that seconds is a number, that username is a, and then of course it needs to call commit, and then there's some error checking. So this is how you can use this in a way, and let it be type safe. Okay, the visitor pattern. So that's the last bit of formal content I have today, and then we can go to Q&A. So the visitor pattern. So why do we want to use this visitor pattern? So there's a number of uses of the visitor pattern. So one of the things that you can do with the visitor pattern is you basically can go into a data structure without knowing how the data structure actually is structured. So you just can iterate over the elements and it works automatically. And normally you'd have a visitor object have multiple different callbacks depending on different types. So basically your data structure can say, okay, if it's an integer, do this, if it's a double, do that, call that, and the visitor calls those things, and it might even have a return value that then allows the visit function to basically have the results in a structure. But it doesn't have to, because your visitor could also accumulate those itself. So your visitor object will be able to respond to elements, and in particular what it also allows is to add all this kind of functionality without having to change the visited object. The object you visit just needs to have the visit method, and then you can have many versions of methods that use this. You can even, in Kotlin, make an extension function upon the visited object to make it look like it's a regular function that does something with the elements, but actually use the visitor underwater to make this work correctly. And a particular thing that you can do with visitor pattern is do double dispatch. So double dispatch is something that, say, Java and Kotlin don't support natively. So single dispatch might be an interesting thing to first talk about. So what is single dispatch? Single dispatch means that the function that is invoked when you call it upon an object depends on the type of the object that you call that function on. So dynamic dispatch, so it dispatches the function based upon that. But sometimes you might also want to do something based upon a parameter. And with visitors, you can actually do that in a limited way, while being type safe and all those other things that we want to achieve. So what does this look like? So in this case, I could have added multiple visit functions. So we have a visitor that implements a visit function, and then when we have another class that uses visitor, and it will just call the visitor with a number of parameters. It could do something more interesting and have some state that it passes it, but in this case it doesn't matter. Then we can have an implementation of that visitor that actually provides an implementation of visit int, and says in this case it calls print line, but it could also say int colon I, so it could do something more, and it could have a visit boolean or visit string, and it could print the contents of your A object in whatever way you like. The A object doesn't need to care. So when we use this, what we do is we need of course an instance of the visitee, we need an instance of the visitor, and then we call the visit function of the visitee with the visitor, and that will print our data. So that is the visitor pattern, and it is quite a clever trick, and it's very close to our callbacks and stuff like that. It is again a way of indirecting, and in particularly what you have often in a data structure is that you actually know underlying types, and then you can call those underlying types with the right visit method, so that the right visit method actually can then work with that particular type. Or you have different objects that implement visit in a different way. So you call the visit function with the visitor, and then depending on so your first function says, okay, I need to do this. I create a visitor depending on what type I am with dynamic dispatch, and then the visitor can be visited based on and then you visit the parameter based upon with the different visitors that you get from the dynamic dispatch, and that the visit function then will call the right visit function based upon what it is. That's how you get this double dispatch. So that was all the content, formal content for the lecture. So I'd like to ask for any questions. In particular, I know many people have questions with the assignment. So any assignment related questions? Okay, what circumstances would we use coroutines? A very common use case, so you can use it for the sequence builder. That's obviously quite tidy. So if you have something like that, I'd say use coroutines. They are not expensive, they're really cheap to use. There's no reason not to use them in that particular case. And for the sequence function, you don't even need the library. This is part of the standard library because it doesn't use most of what coroutines does. The coroutines library provides a lot of extra capabilities. But in the context of Android, when would you use it? When you do things like you want to make a network request and then you want to do something with that network request, it's a very common way of doing this. So coroutines, any time where you need to send some work and then you want to do something with the work when it's done. A coroutine makes it possible to do that in a very natural way, rather than having to do all these callbacks. So if you have something where you want to do callbacks, when you want to make a network request, you want to hit the. Remember, in Android, even accessing a database should not actually be done using the main UI thread. So in Kotlin, a very common use case or in Android, a very common use case for coroutines would be to replace a lot of the async task implementations, where you do something in the background so that it doesn't interrupt your UI. Your UI doesn't become unresponsive. In particular, when we have this with context that I showed you in the example, what it allows you to do is very quickly say, okay, do this in a UI thread, do this on an IO thread, do this in a background thread. So basically, IO and background are different because an the IO pool will create more threads from the expectations that it just needs to. Most of the threads will be spending most of their time waiting for something to happen externally, so being suspended, paused, whereas a background thread is supposed to be doing actual work. So if you have heavy work to do, that's another one. I have one of the things I have an example of. I don't actually use coroutines, but if they were available when I implemented that, I would have. Now I use some really hackish way of doing the same thing. Is I have an algorithm that allows me to lay out a diagram, and I want, partially for testing, partially for that, I want to be able to actually see every move that the algorithm makes to the elements in the diagram. So when it moves something, I want to be able to see that. So I would now use coroutines to basically just in that say, okay, now inform whoever wants to watch it that this change has happened, and then when it's ready, it can say, okay, I'm ready, I've received this. Basically the same way that our sequence generator or sequence builder works. So those are kind of contexts where you want to use coroutines. Anytime where you want to be able to suspend your execution and then pick it up somewhere later. But write your code as if that was just one thing. So you can think in a sequential way, but it's executed in a non-sequential way. That's kind of and in a way that you suspend halfway through, so as chopped up bits. I think that's the way to think about that. Any other questions? Why are there only 4 people here? Okay, yes. I can only speculate why there's only 4 people here, but I suspect many people are in full-on assignment panic mode. Yes. So, and of course, coroutines and DSLs are not particularly closely related to the assignment. I would certainly not advise people to put them in here. So the no detriment rule for late submission. I don't think it applies to late submission. I mean, we don't yet know exactly how the no detriment rule will work out. But one thing that is possible is you can ask for an extension if you say, okay, actually, because of all this COVID stuff, I lost some time. So, because this is one of the few assignments that wasn't extended. I don't know exactly why they didn't extend it, but from my perspective, it makes my marking timetable a little bit better. The dates for the exam, yes. We can have a look at the exam timetable together, possibly. Let me have a look. So we can look at. I will zoom in a little bit. That's excessive. So. So there is an exam timetable, but I do not know exactly what the situation with that is. So let's have a look. So yes, so we will need to be organizing ourselves. So I will be asking the program leaders exactly what they think is a good time for the exam, so that we can run it on a central time. So, but I will be allowing you to have a little bit extra time for practicing it. So Kevin said he would have a look at updating the exam. So we translated the exam into a Brightspace exam. But we have a lot more questions, but we haven't had time to actually create the practice questions into Brightspace yet. So we'll be doing that soon, and then you should have some opportunity to actually practice your exam with some alternative questions and get that, because we obviously are not going to use those. So in this case, so we will be doing the exam online. It will be timetabled, I suspect. So I will let you know with plenty of time exactly when it is, but it will not be any time before the original time, before the exam period in any case. But I'll ask the program leader team so that we do it in a way that is consistent with what else is going on with your other units, and that I'm not letting you do an exam when you're actually trying to finish your assignment for some other unit. So I will be asking that. So, any other questions? How do you push your assignment to GitHub? Okay, so The easiest way is, if you pulled the assignment from GitHub through the repository, then it should be fairly easy. What you need to do then is just go into your IntelliJ. I can actually go to IntelliJ. What you would need to do here is you would go to Git and then go push, and this will push it. So in this case, this is a very complex one, but we have basically you do this and then you push. This is a different kind of project. It's a little bit more complex than what you're looking at. So we have multiple parts of the code with different repositories and a mess, but I could say, okay, send this to the server, push this, and I could review that. So that's how you can push it. Of course, after you committed something. So a key part of that is also that in the Git or version control menu, it used to be called version control. Now it's called, now it actually calls the name that it has. So you need to look at what the local changes are, and that everything there should. So one common error is that students have files that are not supposed, that are. So if I create a file here that, okay, it's a bit laggy. If you create a file and you don't add it, okay, let's do the terminal. Let's say, okay, touch other file.txt. So we have this file that should now be at some point be picked up. So this other file.txt has appeared here. Now we have an unversioned file. That file will not be in your commits. Oh, can't see it. Now you should be able to see it. So we have another file here that I created. It's empty and it's not added to our repository. So we can see it's red. That's the color code to make this work. Black means it hasn't changed. Green means it has changed, but it is recorded. So in our change list, we can see all these files, or in this case, blue that says it has been recorded. This is updating it to the latest Gradle version and stuff like, or Kotlin version. So this file, we don't want any unversioned files normally. We would either have files that are in the git ignore so that we don't incorporate that or that. So there's two common problems that we have. First, you have the possibility that you didn't actually use Git, that you downloaded it as a zip file and now you want to do this. The very easiest way of doing this is to actually go and create a checkout for your project. And yes, you can do that using, so we can get a project from, in this case, from GitHub. So if you log in with GitHub, you can do this and say, okay, I want to actually get, say, this project. I don't know whose this is. I could clone this and then it will create me a new project. But we want the old code. Yes, I know. So you do this, and inside that code there will be a .git directory. It is likely to be hidden in Windows, depending on how it's created. But if you show the hidden files, you should see is this .git directory. What you do is you copy this .git directory to your own project where you have your changes. Now it suddenly has a Git repository without any changes in it beyond the ones that were provided by the template. And then you can you need to reopen your project, so you can get rid of the temporary project that you downloaded for yourself. You have the project where you actually have all your code. You can then, with that project, so you need to reopen that project. You close the project, reopen it, because that will give Android Studio the ability to actually see that it has now Git in it. It doesn't pick it up otherwise. And what you do then is to so then it picks it up, and then you can see, oh, I have all these files that were not added to the repository, etc. So you add all the unversioned files to the repository and you commit it. You can also add them from the commit dialog. When you have a commit dialog like this one, so this one is, you can review what is there. You can also, with these ticks, and say, okay, I want to actually add this file, you tick it. Or you can say, oh, actually, these are separate changes that I want to record separately. You can do this. So there's always a lot of the basically IDE configuration. I'm not sure that it even necessarily needs to be in version control. But there are some bits that you might want to that doesn't change all the time. They actually reflect your project. So when we update this, etc., you can do all those things. So you can even say only this bit should be included. That's a nice trick that they added in IntelliJ. So you commit that, and then after it you can push it. You can also commit and push here directly, which will just call the push dialog after the commit has been completed. Yes, and in the commit you can do various things before you commit, like you reformat your code, or you check to-dos, or stuff like that, or update copyright things, etc. So there's a lot of capabilities there. But so that's the easiest way. If you have your own repository, what you need to do is add the Classroom repository as a remote. Then you will probably say, you probably want to make a copy of it just as a backup. What you can then do is you can rebase your repository upon the remote repository. And if you started with the base code, that should just work correctly. There are other ways you can do things like force pushing. But you say, okay, yes, I'm just ignoring the original things and I'm just pushing my project with my changes. It is a little bit more advanced if you did that. So if necessary, ask some help. But yeah, so that's what you want to do with GitHub. So if you say you tried pushing it, but it has not worked, what is the error message you get? That's what I would be asking. What is the error message you get? By the way, so this is the Classroom interface that I see, so I can see everyone's submissions. So I can possibly sort. So there's people. So a lot of people. So there are some people that did this. So this tick means that the test suite passed, because I actually enabled it to do the test suite. So some people haven't got it working yet. But yeah, so if you can tell me your error message, I can have a look at that. Okay, and the camera stopped working again. How do the let me have a quick look, see if I can make the camera work again. It says it doesn't yeah, the camera is not working at the moment. Just leave it now, I think. So Run field for master. Yes, we need some more error messages, or we can have a look at it in Virtual P201. One thing you might want to do is first update it. Oh, no, run field for master means your test suite didn't pass, I would say. So I can have a look at your repository if you can give me your username, but so how do listeners work to change the UI? So what you want to do is when you create your game so ideally you have a property setter, or your view has the game property. The view registers itself as a listener to the game. You might want to set the game actually through the activity. And that means you need to have your game view actually implement a setter to make sure that when you update the game, it will listen to the new game and stops listening to the old one. And when you have such a game, we can actually so that makes the UI be able to know that the game changed. And when the game changes, it will call this the listening function, or listening object. That could just be your game view. And when it has this method, it can call invalidate. So let me have a quick look if I can show that through Android Studio. Or let me have a look. I might open this one directly here. Let me have a full screen. And so the camera doesn't work anymore. So I don't know what's going on today with the camera. So when we have a game, we would now, so this is the kind of thing we have in the game. How do we do listener? So we have our app. Let's close all screens. Let's close this bit. When we have our app, we would have a view. So we would have a game view. Which would be a class that inherits view. Yes, Android view. And then we need to implement the constructors. I'll skip the last one because we don't need that one, because I actually know that we don't need that. And then what we do is we have a property. So var game is say student.box game. It can be any .box game. And is so we initialize this somehow with a default setting. My one doesn't take any, the default implementation has no parameters yet. So this will work in my case, it will be correct. So the getter is fine, but we need to actually override the setter here. So set the value. So when we have a value, we need to do something. First, we need to say, okay, field, which is the current value of it, dot add on, so remove on game change listener this. So this will make that the game view is no longer a listener. So we need to also, now we get, okay, need to actually implement that interface. Okay, let it implement that interface. We just do the quick fix. And what do we do when the game changes? Well, we call invalidate. That will get our game to redraw itself. By the way, your activity might also want to listen to game changes if it wants to do things like display the current scores of users in a text view, or handle game over by, say, displaying a game over menu. Your view could also handle game over to say, okay, now you can no longer, I will no longer respond to any presses because the game is over, it's not valid to press a button. Or you could just, when you're in your game, in your button press handling, say, okay, the game's finished, I'm ignoring it. That's another way. But if you want to disable, say, make your thing look differently when the game is finished, you can do that. Of course, you can also do that in invalidate, check it in on draw, and then, because invalidate is also called on the last move, should also be called on the last move. So anyway, in our setter, we now removed ourselves as listener from the previous value. Then what we need to do is a field, the field equals value, and then we add it to value, so value dot add on game change listener this. However, there is one particular thing you need to be careful with. When you initialize a property, that will not call the setter. So if we want to make the initial game also listen to, we need to do this as well. So in this case we do we call it. I use also because otherwise we're dealing with two this objects. We could do that, but it is tidier to use also in that instead. So it dot add on game change listener this, and this is now our game view. Why do we use also instead of let or something like that? Because also returns the original object, the student.box game. So this is how we can have a game object. We could also say, so sometimes you don't need it to be student.box game, you can just use .boxes game. So this is how we set the listener initially, and then we update it whenever it is set to a value. And that's how you can also have your activity pass it a game with a different configuration, maybe a computer player in there or a different amount of dots or boxes rather than the default. So this is how your listeners work. So in your game, you just you find the line that was pressed, press draw line. Draw line will at the end of the day call on game change, and on game change sets invalidate, which will cause your game to be redrawn. Because invalidate does that. So if we do invalidate and then Control Q, we can see here that it will actually call on draw if it is visible at some point in the future. So it won't exactly tell you when, but it will be called. So this is how you use listeners. This is how to make that work. So we need the custom setter to make it nice and tidy if you want to be able to update the game from outside. Yeah, if you find it also a bit confusing, you can instead use an init block that you do it instead. So add on game change listener this. In that case, make sure you don't have the also, because the default implementation does not check that you don't add the same listener twice. We'll happily add it twice, requiring you to remove it twice as well. And it will call your own game change twice, which is also not necessary. So that's your listener. So any other questions? No other questions? It will not override your current work. If you're worried, so make sure you commit locally first. But if you're worried, what you can do is to try to create a copy of your directory or of your so that you always have your original stuff. But yes, pooling will not actually update it. It will try to merge. And then you can decide how you are merging it. And in Android Studio has a quite good merge tool available. Yes. But just make a copy of your folder and make sure that it's you can always go back. If it's committed, you can go back from the history as well, but you don't necessarily want to do that. And yes, you can see, if you do a merge, you can see from the history, you can go to the log and actually see all the changes, and you can just go to the previous version. You can see what that version was. You can compare this file with the local, and then you can even transfer your changes. Of course, in this case, there's no differences, but etc. So there are some code, some changes I have here, but yeah, this one, there are some changes, so you can compare it with local. In this case, the current one, but compare the before with local, we can see the actual changes. Oh, I actually want to go back to the old version. You just click there and say, I want to have that. So the whole point of version control is that you never lose any work. So yes, you can see changes, etc. It is possible to do it quickly. The UI, start with the Connect 4 stuff. Yes. But yeah, if you have particular issues, Virtual P201 we can have a look at it in your specific case. And remember that in any case, even if Git didn't work, if you submit your stuff properly, that's okay. So you submit it using the file, and then there's export project to zip file. Think in Android Studio, it's slightly different, but yes. So yeah, so you want to make sure that the logic is implemented correctly, and the test suite should help with that. You might want to take the new version of the test code that I published. So I can show you quickly what I did. So show the difference. But basically, what I did is for all this stuff, I can just do it this way. Basically, I add a lot of textual error messages that you see expected. I even found that one test is duplicated. It has a different name, but it does exactly the same thing. So I tried not to change anything. There's one thing that I changed here, but because the previous test wasn't actually correct, a pair is always a thing. But so yes, it should return always 1 or 2 non-null values. So this one is updated. Everything else is just more text. Textual explanation if there's an error. You might want to use this if you find that you struggle with the errors. And it is available through Brightspace. But in general, I'd say first do the to-dos, only then look at the tests. or try to pass all the tests. And also look at on Brightspace, I actually put out some guidance. So when we look at the, you should be able to see this now, isn't it? Yes. The announcement of the live stream. Let me put it. Do it this way. So when we look at the assessment part, oh no, so not there. The assessment part, here is the updated test code. You can download that and put it in if you want to. So it's not mandatory at all. It literally just changes the things. So when we look at the there, so there's a number of available documents there. Okay, now this is assignment help. I think in the assessment section. There is. Oh, I have to look at it where we put it. Yeah, the warning item, this one, the common errors. It also tells you exactly what drawline needs to do. So when you look at this, there's some common ways that people do it wrong. I underlined the bits that you want to do correctly. There's also the bit here about height. That should be Y. Was wrong in my example code, my video. The same for boxes. You want to return student box. Technically it's not required, but it makes your life so much easier. Again, don't create new boxes. Just look them up when you do the adjacent boxes. Obviously you need to have also the vertical ones. In drawline you need to do all these things. If the line's already drawn, throw an exception. Update the drawn property. And for each of the adjacent boxes, you need to determine whether all its lines have been drawn. If they are drawn, you update the owning player. You also record that the box, store the fact that the box was completed, because we then need to be able to give the current player another turn, as in not update who is the current player. If any box was completed, we might want to check that the game was won. You could do it cleverly and say, okay, if either is one box was null or both boxes were completed, then only can we have a winner. If there's one box that wasn't completed, we cannot have a winner. So you could try to do that cleverly. I'm not sure it's worth it, but we only need to check whether any box was completed anyway, so we can say, okay, only when there's a completed box can we have the game completed. If not, we update the player. This is the clever way of doing it, rather than using a big nasty if statement. The modulo operator will just wrap around the number. So it does the remainder after dividing with that particular divisor. So we have 2 players and the current player index is 2. That will end up the remainder being 0 if you divide it by 2. Or if you divide it by 2 with remainder. And then we call play the computer turns if no box was completed. If that happens to be a human player, what is the new current, then that will just not do anything. And we also need to remember to call the change event, or if the game was won, the game won event. There is the get scores function that you need for the game over thing. That get scores function does not meet the exact same format as the scores function, as the scores parameter to the game over thing. So what you can do is either fix get scores itself, or possibly the easiest way, use this bit of code that does the transformation. So it basically goes through every value with the index and the score value, looks up the player with that index, compares that to whatever the score is, and that gets put, and map index returns a list of all the values. And that's the scores, and that will meet exactly what was needed in the fire game over function. So create game. So one of the things that was there is many people would use something like this in the test create game. That will fail because you need to make your create game work with what was passed in. So just use this rather than having hard-coded values, because many things will fail if you don't use the hard-coded values. And it's not correct to do it either. So if you'd have this in your submission, then we would come in and change this and make sure and look at the tests if they actually pass the right value. It's not about you being able to bypass some failed tests. So look at this as well when you implement these, including what does drawline need to do. So any other questions at this point? Okay, so thank you. You answered yes for being here, and next week we'll have a revision lecture, and I hopefully also have a little bit to show you about the exam then. Okay, yes, I hope to explain everything. So yes, look at this stuff. There's a lot of material available that Kevin and I have created that should help you to make it work. But yeah, the biggest one is don't start fretting about the tests first. First look at what the to-dos need to do, and then look at the things. So and again, with the to-dos, you first want to look at basically make pseudocode as in drawline rather than starting from scratch and immediately trying to see how can I write that as Kotlin. First think what do I need to do, and then how do I write that down. So then I thank you for being there, and I might see you in virtual P201 or otherwise. So thank you.